morning. This is the Rubik's Cube Club, week 7, and we're talking about the stepper motor today. And we want to talk a little bit about the download of this program. So we're going to click on the hybridplc.org website. We're going to come down to week 7, and this says week 7 stepper lab. So you click on that, and up comes. I already did it once, so it's going to do it again. It's a zipped file for Stepper Rubik's version 19.12.4. So I already did it once. Now I did it again. So now I'm going to come over there, and I'm going to look at it in the it's in the download, and I'm going to look under File Explorer and under the downloads, and you can see that I already did it once. But now what you do is you click on it and you extract all. And once you've done that, it gives you this, which is the extracted version of the folder. So here you go. Now here is the Stepper Rubik's version 19, and some of you have version 19. So if you do, you just click on this and it takes off and runs. However, if you are a version 20 person, and many of you are, you have to start by using TIA Portal version 20. And then you have to bring in that file. And remember, it's in the download folder, so we're going to have to find it. And we'll do that here in a second. And it says open existing project, and you browse, and you go under up here, the downloads, and you say Stepper, this folder, and this folder right here, which is, now here you click on version 19. Okay, you click on that. And then it's going to ask you some questions. So you're using version 20, but you're bringing in a version 19, so you're going to have to do an upgrade. And it's going to ask you a couple questions here. So do you want to do a list? And it says, yep, upgrade. Now it's doing it. So when you come into this, it's version 19, but when you're done, it's version 20. Now you can't go back to version 19. Once you do it at version 20, you're stuck at version 20. You can't do anything about it, but it's going to take a little bit of time to do this upgrade. So while we're doing this upgrade, I just want to remind you that at this point in this course or in this program, you have the option of going back and looking at some not old programs, but some other programs that ask you to start programming on your own. So under the Hybrid PLC, under the texts, Hybrid PLC and Hybrid PLC labs, there's some more labs that you can do. Under Chapter 5, there's a lab. It's the coin lab. And starting in Chapter 7, there's more labs. And you say, well, these are the same labs we already did. It's the cash register and it's the traffic light. But each of those has several options or variations. And some of those variations require additional logic, and that would be good for you to go back and start thinking about how to program some of that logic for yourself, because it's just good to start practicing doing your own coding. So anyway, click on Project View, and we come up here, and it's set up already for IP address of 3 for the PLC and 2 for the HMI. And it should be all set up for the devices and networks. And I'm going to check to make sure, but it should be set up correctly. Now this is the network connection. This is the other connection that you have here. And it says HMI connections. And I think if I click on this, see, it says this, and this is okay. This is what you need. And you should be okay with this. Okay. So you have both. And if you don't have both, if you don't have this one, if it doesn't come up with this one, click on it and add it. But you've got it, and you don't have to do anything about it. Okay, this verifies that it's there, your HMI connection. So now I come back. Now there has to be a strict order to this or it won't work. So you have to come back here under Devices and Networks, click on the PLC. Now you can click on it or you can click on the PLC itself and then you click compile, or you can right click here and you can compile down there. But I'm just going to compile the program, see if it works. Watch it spin. And it should be able to. But now in the past, we just said download, but do not do that today. And the reason for that is because the certificates, which is the date that it was last compiled, have to be the same for the HMI and the PLC. So here's the PLC, and it says, you know, you're done, you got no errors, but don't download. Stop. Don't do the download. You have to come over here to the HMI and click on the screen and click compile there. Now, once you've done that, you can download, but the certificate for the compiled, when it's compiled, the date that it's compiled, puts a certificate in that program, and those certificates have to match by date. So unless you have the same date, you can't download to your PLC, which is kind of a trick. But again, you have to click compile PLC, compile HMI, then do your download to your PLC. And in that order, explicitly. And if you have problems with this and it doesn't work, especially the HMI communications to the PLC, there are a number of other checkpoints that you need to do, and they're listed in the first few pages of the text. And it's like page 16 through 20. There's more hints of things that you might try if you have problems. Week 7's lab, the stepper motor program wired. And this gets you into the idea of moving of something with a stepper motor, which basically it goes by steps or by pulses. And the pulses come from the PLC, the output of the Siemens PLC. And they come to this little controller box, and this is the one wire that's from the one output, and this is the other wire that's from the other output. And this one gives you the number of pulses or how far it's going to go, and this gives you the direction. And this is the motors. These are the motors that are going to be used to power the Rubik's Cube project. And this is the interface definitions or how that is done. This is inside the catalog. Now there's two different varieties. There's the 542 and the 566, and they're both 556, and they're equivalent. So all the directions here are the same for each, and you should be able to find these. There should be a couple of three of these systems separate from the Rubik's Cube in your facility, so you can have access to these as well. So the controller is used to drive the motor, and you drive the controller from the PLC. Okay, so the pulses come from the PLC out of output 0, and you see the flashing light coming out of output 0, and depending on whether you're going clockwise or counterclockwise, the second, or input 1, O:0/1 is turned on. And if there is a red light on the controller, that means that there's an error, and the only way to reset that error is to take the 24 volts off of the controller and then put it back on. So you have to power down that controller. The 24 volts that goes to that controller has to be turned off and then turned back on. And these signals you don't need to worry about. Just say it works without coming out of the program controller, and that's all we need to know. In essence, they're using this one over here on the right to do the control. And then we have an HMI screen. So basically, this is a screen that we would use using the simulator on the computer screen, and you can toggle this on and off. This is a toggle switch, and it's the power, and you have to turn it on, and then you have to reset the controller with this, and then you come down here and you do a relative move, and if you put it in plus, you will go in the one direction. If you go minus, you'll go in the other. And the speed is this determined over here. And halt is, I very rarely if ever use it, but if it won't turn off, you can always turn it off with the halt command. And again, you don't need to read through all this, but this is the configuration that we had to do in order to get this to run, and this is part of it, and we had to set all these things up. This sets up the outputs, and this is the commissioning screen. And again, if you are active with your program, this does not work. But before we activated the program, we went through and did all the activation with all the variables on this screen. So that's already been done for you. Now again, this is the wiring, and again, I recommend that you would use these circled, the dip switches that are located right here with these settings. These are the settings, and I think half power would be okay. Either one, it doesn't really matter on this switch 5. And notice that you bring in power, the 24 volts from here. Here's your 24 volts, and here's your 0. This would be your L. This is your M coming from your power supply, your 24 volt power supply. Here's your 2 signals coming from your outputs, and these are going to the motor, and these are the colors that are going to the motor. The black, green, red, and blue are the colors that are going to the motor from these terminals right here. So a suggested setting for the dip switches, which are located right here, would be on, off, on. And again, this is your wiring to your direction and your pulse, and the rest of these are all tied to your M or your 0 volts, and this would be your 24 volts and your 0 volts here, and these are your motor. Okay, so for this lab, the program is furnished. Download it, compile, download to the PLC, and then compile but run the HMI as a simulation as we've done in the past. Turn on the power, to use the reset button to reset. This will enter some numbers into the stepper motor. Start with 100 and 100 first, then click the relative move. Does the motor turn? See if it turns. See if it doesn't, see if the pulses appear out of the 0.0 LED and on the PLC. And if you can't get it to run, eventually you're going to have to call somebody. And I said call Jared, or you can call me, or you can call Pete, but we'll help you if you can't get this to work. Okay, so we're going to try this now, and we're going to go to the program and see if we can get it to work. And let's try it now. So I've already downloaded the program, and here's the HMI program, and I'm going to go down on the HMI screen, and I'm going to click on compile, and then I'm going to click on simulate. Okay, start simulation. And then I'm going to come over here on my OB1, and I'm going to look and see my program block, OB1. I'm going to play that OB1 over here on the left. Okay, click the glasses, and then I'm going to bring in the simulation program over here on the right, and I'm going to click on, it says there's a home button. We don't use that one, but we do use the power, and see the power is off. I'm going to click on the power, and I'm going to see if it turns on. And it turned on. Now I'm going to come up here under the reset and see if I can do the reset. Click on reset, and I'll watch this go to from false to true. Now I've reset my drive, so it's all cleared up. If there's any problem, it's ready to go. Now I'm ready to go, and I'm going to do a relative move. So first of all, I have to put in some numbers. So let's put in 100 here, 100 for distance and 100 for speed, and click relative move. And I'm going to show you the motor here, and I'm going to hold it up for the screen, and I'm going to show it to you as I'm going to do the relative move. Now that's a relative move of 100. Okay, now I'm going to do a minus 100. Now you remember which way it went before? Should go the other way. Let's do it again. Let's do minus. That's plus 100. Let's go minus 100, Ted. Minus 100. Okay, so this should be, no, it's still got plus in there, so let's go. It's only taking a plus. I got to get a minus sign in there. So okay, now it's got a minus sign in. I'm going to hit enter. Now watch it go the other way. See if it goes the other way. You know, see it went the other way. So it's minus 100 and it goes the other way. Now I'm going to do plus 100 again. And watch it go the other way. See, it was the other way. Now I'm going to go 500 now. 500 instead of 100. See what it does. It should go 5 times. It should go further this time. Okay, let's go 500. See, it goes all the way around and a little bit further. Okay, that's 500 pulses. And then I'm going to go a little bit faster speed. I'm going to go 200 instead of 100 for my speed. So it should be a little bit faster now. See it go faster? Okay, so this is control of the actual speed and distance of the motor with the relative motion. So this slab is pretty much to set us up so that we can do the rest with the Rubik's Cube, and the Rubik's Cube will be starting our next lab. We start writing programs for that, but now is the time to actually understand how the motion works with this. We're giving you the program, but a chance to set it up and watch it run is what this lab's about. So if you have any questions, please give us a call. Thanks. Have a good day.